So we are going to study about flotation. So here this blue object is the one which is floating in the water, and this water is being kept in a tumbler, say, and this green line, this line shows the water level, and a part which is shown in this red mark is the immersed part, and which is inside this water level. So if this body floats, it is at rest. That means it does not have the tendency to go downward, or it does not have the tendency to go upward. That means it's at rest. So the net force acting on this object should be equal to 0. Now we are considering the forces acting on this object. Obviously it will have weight acting downward, and this weight will be pulling the body downward, and there will be a force called buoyant force, and that buoyant force is caused because of the displacement of water. When this much portion is immersed, that much portion will have to displace a particular amount of water, and that displacement, that water will try to come back to its initial position, which imparts a buoyant force, and these are the two forces acting on this body. For the net force to be 0, these two forces must be equal. So we are going to find out these forces separately. First, weight. For finding the weight of this body, first we are considering the volume of this body. The volume of body as Vb. Let the density of the body be rho. And now weight of the body is equal to volume of body into density of body into acceleration of gravity. That is equal to Vb rho g. So weight is completed. Now we are going to look at buoyant force. Buoyant force is equal to weight of the water displaced, and that weight of the water displaced is equal to volume of the immersed part. Volume of the immersed part, this part, that will be the volume of the water displaced. So volume of the immersed part into density of water, that will be mass of water displaced, into g, acceleration due to gravity, that will be the weight of the water displaced. So that is Vi rho Wg. Now we have obtained two forces, buoyant forces and weight of body. For a body, if a body have to float, then net force should be equal to 0. That is, buoyant force which is acting upward should be equal to weight of the body which is acting downward. That is, Vi rho Wg is equal to Vb rho g, where Vi is the volume of the immersed part, rho W is the density of water, Vb and rho we have explained it earlier. So the net force is 0. The weight rho Vbg acting downward is equal to the buoyant force rho W Vag acting upward. So when weight of the body is equal to the buoyant force, the body floats. That is the case of